Hey, everybody. Welcome to another episode of Mavens of Data. We've got an awesome session planned for today on data scientist and data analyst career paths. And we've got two awesome guests. So Chris, Alice, welcome to the show.
Hello.
Hi.
Do you each want to do a quick intro about yourself for the folks in the audience? I'm sure some of you know, some of them know you already, but.
Sure, I'll start. My name is Alice. I'm a data science instructor for Maven Analytics. I also teach machine learning at Northwestern University, and I'm the author of the SQL Pocket Guide. And in the past, I've held roles as a data scientist, data analyst, IT consultant, engineer. I've done a lot of different things in the past, but I'm pretty happy with this data science path at the moment.
Yeah, and hard act to follow there, but yeah, I'm Chris Bruehl. I'm the lead Python instructor here at Maven Analytics. I've been here for almost 3 years now, but rolled out our Python series, which is really designed for both analysts and data scientists alike to get familiar with the Python data stack before moving on to co-develop the data science and machine learning courses we have in our library as well. Prior to that, Alice and I actually met at a boot camp called Analyst. It was an intense data science program. That's where I got my first foray into teaching. But prior to jumping into data science and analytics education, I was an industry data scientist for about 4 or 5 years, starting in the insurance industry, where I got to work on all sorts of fun problems like customer retention, conversion, fraud detection, et cetera. So pretty fun and broad experience, and it's been a pleasure to jump into education and watch people learn those same skills and add value in their companies. So excited to be here.
That's awesome. Yeah, I mean, I'm glad everyone can see that we've got a ton of experience here in the room, and you guys are ready to share some of your insights from those storied paths it looks like you've taken. So these are some of the key topics that we're going to hit. So similarities and differences between both roles, what the career paths look like for each, and where you should focus if you want to get job-ready skills and land that role for yourself. So let me close this out. And let's get started with question number 1. I mean, I know you guys have already done an intro about yourself, but I want to learn a little bit more about your backgrounds. I know you're data scientists now. You've each kind of talked about your experience, but is that the career trajectory that you always planned? And at some point, did you ever work as a data analyst along your journey? Alice, I'll go ahead and hand it over to you first.
Sure. So I would say this is not the career I planned when I was an undergrad. I studied engineering, and data science hadn't really come into the world yet. So I would say I started, my first job out of college was in technology consulting. And within that field, I held a lot of data analyst type roles. So I was a reporting analyst, a data analyst, a business analyst. And that's when I really got into Excel, and I got really excited about Excel, and I was excited about like VLOOKUPs and pivot tables, and I just loved it so much. And I really liked being a data analyst. And then at one point, I just really wanted to learn more. And so I saw the databases that the data was coming from, and I wanted to learn more about that. I wanted to learn more advanced statistical techniques. And so with that, that's how I went into data science. And then I've been a data scientist ever since. So yeah, I've seen a little bit of both worlds, and yeah, they both have their pros. Not even that many cons. They just both have different pros.
Do you find yourself still using Excel even now that you're a data scientist?
All the time. Chris and I have had this discussion before because we've met data scientists who are very pro like Python or R, and they're like, you got to do everything in Python, but we're always like, use Excel. It's such a powerful tool, so popular, and it really makes life easier a lot. So,
yeah, I mean, and even if you are allergic to Excel, like if you work in a larger corporation, your stakeholders, your managers, are going to be wanting to see those final numbers in Excel. So, and a lot of the times you're making presentations in PowerPoint, so your data visualizations are going to need to be in Excel. Like you'd have a Python script that wrote out to an Excel sheet, and then I'd take time to format the chart and all that stuff. But like, it's really hard to avoid Excel completely. And honestly, like, you're doing yourself a disservice if you're not like, able to at least work your way around a sheet and do the basics. But beyond that, I'm pretty bad. But
I was just going to say, because I've heard you say, Chris, that you were never a huge fan of Excel to begin with. So it sounds like Alice, that was the platform that you took to learning more. So what was the difference in your path, Chris?
I wouldn't say that like I didn't like Excel. I I think that like in my roles, like I didn't have like a role where I had to be an Excel power user before I went to school to get like, coding skills. So like I had to do just enough to like move data around spreadsheets. And then I studied like the first language I learned was SAS, and then Python, but like in SQL. So like by that point, like all I had to do was get my outputs into an Excel sheet. And then from there, like fairly intuitive to learn how to like build charts, format them, et cetera, because it's point and click. And a lot of the times we had templates as well that made it easy to align like that with. But yeah, I can make a table. I didn't like hate it. I can make a table, but when you ask me to do complex like joins or lookups, that's when like I start being like, I need to get back to SQL very quickly.
Nice. And was there ever a point where you were like, I want to become a data scientist, or was it something that happened a little bit more organically along the way throughout your roles?
So for me, like I studied econ in undergrad, and like I always had this really strong fascination with like understanding data and how it impacts the world. Like when I was 4 or 5, like I would wake up, my dad would read the newspaper, and I started asking questions about stocks. Like, and I would look at the stock prices and be like, why did the stock market go up today? And all of that stuff. So I always had this like innate curiosity about numbers and their impact on the world, which is why I sort of fell in love with economics. And there was a point where I was considering, a PhD or maybe law school, but it was kind of in the wake of the financial crisis. So I wasn't really sure. And I had this opportunity to supply chain management. So I was like, I'll take a year, move to China, work in manufacturing and see how that goes. And it was a very cool role. It's very operational, but like I always found that my favorite days on the job were when I got to sit down with the spreadsheet, my poor Excel skills, and try to make sense of data, understand, how can we reduce costs in terms of shipping? How could we reduce lead times? And that's sort of what led me to go back to school to get more skills in data analytics, I got a master's in data analytics at NC State. But yeah, as Alice mentioned, like there weren't really these types of applied data analytics or data science programs when I was first entering school. Now they're extremely common, but like I think Alice and my programs were some of like the first 2 or 3 in the country, in the United States. And we were one of the first couple of classes in those. So we jumped in we were at a very good time and place to like match our interests with this emerging and lucrative role. But that's really, it was like, oh, wow. Like I was actually looking at supply chain masters because I wanted to transition careers and accelerate my career a little bit. But then in the process of looking for programs, I found that there were these data science master's programs. And that was like much more appealing to me because I didn't necessarily want to be pinned down to a single industry or domain. And thinking back to my undergrad, like some of my favorite courses were statistics, applied linear regression, probability modeling. And I saw that I could, really get the next degree of skills there, as well as some hard skills in SQL, coding, et cetera. And that was like, oh my God, like this is exactly what I've been waiting for. I'm so glad. Like, yeah. And that's, and my life has been amazing ever since. So it's a great decision.
I would say from my end, it was a little different because I actually didn't know what I was getting into. And then once I got into it, I feel like I kind of stumbled into it. And I was like, oh my God, this is so cool. Because for me, like I said, I loved Excel so much. And I was just reading an article one day, and it was about, this was like over a decade ago, it was about how Target had come up with some algorithm where they were able to predict which of their customers were pregnant before they even knew they were pregnant or something like that, or before like they told people they're pregnant. It was something wild like that. And I was like, this is so cool. What is this field called? And it was called analytics. And then I just like came upon a certification or a program, like in an ad or something for analytics. I was like, oh, I'll just give this a try. And then once I got into it, I was totally hooked because it's just, I think it's like a specialization within data. I think it's like data analysis is very general and then data science is very specialized. And then I just felt like I could more deeply understand like the math and the coding aspects, but also doing a lot of data analysis, because that is really the core of what we all do is data analysis.
I love it. I think that's fascinating how that an article kind of led to that path. And again, eventually you both became data scientists. So can you talk a little bit more about some of the specific work that you did as data scientists, and maybe how you interacted with more, traditional data analysts in those roles. Chris, I guess I'll hand it back to you.
Yeah. So my first role, it was like a perfect first data science role because I joined a team at Liberty Mutual Insurance, which we were focused on optimizing customer service, right? So one example of a project we would work on is if a customer called into a customer service center and said, I want to cancel my policy, we had a specialized team that had more tools to potentially retain customers. So we could maybe lower their price. We could, talk to them about whether they needed certain types of coverages. They were essentially very skilled sales agents almost, but they were in the customer service team. But this team was very small. And so we had to prioritize which of these calls we needed to send to people that were canceling. And so we wanted to focus on the people where they would get the most benefit or lift in probability of retaining if they went to the specialized team versus if they were handled by a general customer service rep. And so when I came in, I was on what was called a model monitoring and optimization team. So I wasn't building these frameworks from scratch, but I was working on understanding, how well the model was performing. Is the performance decaying? Are there any opportunities to improve this model? And so my first few months on the job, I was really performing analyst work, just understanding, how this model was improving our operations and whether there were more opportunities for improvement there. And then after a few months of that, that's when I shifted to, getting more control and responsibility over, making this project my own and refitting the models and looking for new opportunities to optimize this project. And so on my team, there were, combination of data scientists and analysts. Analysts had a little bit more of a reporting role. And then I had a little bit more of a, data science. I was responsible for the model itself. And then the analysts are responsible for understanding, basic metrics about this. And it was really cool. I think in terms of data scientists working with analysts, domain specialists are your best friends. So if you're ever a data scientist and you're working on building a model, before you even start fitting the data, you should be talking to people who are very familiar with that data and understand the processes that generate the data, understand the processes that you're trying to fit a model on. And typically analysts that have been working with that data for a little while are going to be able to give you so much more information than you could ever get from EDA. That's one of the things that's hard to teach, right? But if you're talking to people that understand the processes and the data deeply, that's what's going to give you the intuition for, how to build your model, how to implement it, what the potential risks of the project are, and whether it's even feasible. We used to laugh. I used to kind of jokingly call our data science team the ivory tower at Liberty Mutual because we would always talk about ways that we could make our customer service reps more efficient. And if you've ever been to a call center, they are extremely under pressure. They're taking dozens of calls per day, dozens of calls per hour potentially. And they have all of these pieces of information that are firing on their screen related to the customer, et cetera. And, I had to go sit at a call center and watch this. And it totally changed my perspective on what was possible in terms of data science. Because I then understood that these aren't just cogs in a machine. These are people that already have a ton of competing priorities. So I need to be very careful about how I think about introducing data science into their daily work, and talking to experts and sitting down with analysts as well. Understanding what the constraints already are is super important. And if you're not talking to your analysts as a data scientist, you're probably not going to be that successful.
Yeah, I would agree with that. I'd say, for me, my first true data science job was right out of my master's degree. And I was the first data scientist at a company called cars.com. And when I went in, because I was the first person in my role, it was kind of undefined. And I had to spend my first month just talking with people. And the more I talked with people, the more I realized everybody knows so much about their specific fields. And then my job is really to bring it all together and combine it with all the algorithms I just learned. So for example, I talked with a ton of the data analysts on the team who knew all the questions that the sales teams were having and that the customers were having. I talked a lot with our data engineers who knew the data better than anyone at the company. I worked with this domain expert who knew everything about cars. It was pretty fun because one of my first projects was I had to look at for all the car manufacturers out there, which ones were like each other's top competitors. And what I ended up doing was, because I had talked to the different teams about what data was available, what questions people were getting from customers, I was able to create this visualization where you could see all the manufacturers right next to each other, and then they clustered into a few different groups. And it was really cool to see that, but I wasn't able to verify that. I showed it to the data analysts and the domain experts, and then they're like, oh, this makes sense. This doesn't make sense. This is what you should name those clusters. So I'd say it's a really collaborative process. And I think there's just so many different data roles out there. Like, you could be a data scientist where you actually apply the algorithms, or you could be a data analyst who works really closely with the data scientist who applies your like domain knowledge, right? So there's just a lot of niche roles within data. And yeah, I agree. Like, everyone really works together. And sometimes I do feel like this data science title is kind of put like on a platform, but it's really just another member of your team with some specialty.
Yeah. And the sweet spot is really like, as a data scientist, when you build a model and you bring it back to analysts, and like, for example, if I built like a classification model and I show them that there's 10 variables that are important in predicting this thing, right? And like the analysts are like, oh, 8 of those make sense. And then 2 of those I never thought about, but that gives me more insight in another area to look into. And that's like the dream, is that like, that like you're not completely off in the wild doing, because like if you built a model where the analysts were like, I don't understand why any of those variables are important, it probably means that you didn't understand the problem and you probably need to go back to the drawing board. But like if your intuition aligns with people who work deeply with that stuff, but then you're also able to uncover a few more, areas, like I'm sure with clustering, you probably have done that as well. Like that's the dream, is that like, wow, like we work together, it makes sense to all of us, and now we can drive the business forward because we collaborated in this way, and our intuitions are like aligning with the data here.
And that's why we always tell students about like how communication is such a big part of data science and data analysis, because people often focus on the data part, because when we're teaching you the technical parts, right? But half your job is collaboration and like understanding what the actual problem is and interpreting things together.
I love that. So to that point, Alice, I mean, we see these career paths as not completely different, but separate, right? And we're talking right now about how they're just so intertwined. So what would you say, you mentioned communication skills already, like what other similarities are there between both that maybe a student that is still on the fence about which career to pursue could focus on first, that would still allow them to then choose because there are skill sets that they need to build anyway. And these can be technical or, to your point, soft skills like communication.
I would say the general skills that I'd say both roles need is just some interested in data, like looking at tables and exploring data, and definitely the communication piece. And then for me, the difference between the two roles, I feel like data analysts do more of like the communication and like gathering requirements and finding insights. That seems to be more a data analyst path, whereas for data scientists, yes, you do data analysis, you have to communicate, but it is a deeper dive into the math piece and then the coding piece. So that's really the main differences I see. But yeah, I would say in both roles, like some level of data and solving business problems.
Yeah. And I mean, I think if you're kind of just dipping your toe into the data world, like, the skill I would suggest learning first is probably SQL. Like that's a skill that is universal across almost all data roles. Like before that, you might take a single Excel course, understand basic, aggregation metrics, visualization, just get your feet wet with data analytics. But like, if you're serious about getting into data, I would then consider, really learning SQL, because whether you're an analyst or a data scientist, like your data lives in databases, and you have to before I build any models in Python, I'm extracting the data from databases in SQL. And that'll also just give you a really good sense for the types of analytics you like to do. And, from there you can, determine, like, I think the other big thing is, do you really like math and statistics is an important question to ask yourself when you're considering analytics versus data science. Like, you don't have to be like a PhD level math student to be a competent data scientist, but you do have to really like and be able to understand relatively complex statistical concepts. And if you're more focused on, I think if you consider yourself more businessy and you want to really be in the room with conversations about strategic analysis and driving the business forward strategically, data analysis might be a better fit. But if you're really focused, if you really like engineering or optimizing processes, that's where data science is a better fit. And that does require a little bit more math and statistics. So if you find yourself allergic to math and statistics and maybe coding as well, then I might steer you towards analytics. But if you do really like that technical aspect and find yourself taking courses almost for fun, that's probably a good sign that data science might be a good route for you there.
I love that.
I just want to highlight the SQL piece, because I completely agree with that. And I feel like that's not emphasized enough. Like, often as a data analyst, you'll start with Excel, or as a data scientist, you start with Python. And then the second thing people learn is SQL, but it really should be first. Like, I just feel like SQL introduces you to how data is structured. It opens the world for you in terms of how data is structured, and also like it's a little taste of coding, because it's not too intense yet. So I always recommend, if you're completely unsure, like, you want to do data, but you don't know where to start, like, learn a little Excel, learn a little SQL. And then from there, like, maybe you go into data science because you like the math part. Maybe you go into data engineering because you really like SQL, and then you can dive into data engineering, right? And then you start to read blogs about all these other niche roles, like product analytics, or I don't know, user experience. I'm just thinking, like, there's so many roles out there. So there's just a whole world of possibilities. And I think, SQL, once you understand it, you understand the different paths you can take.
I love that. And I love that. I mean, you mentioned SQL and Excel is what we talked about, right? To get started if you want to be a data analyst. And what we add to that usually is that, the dream analytics tool stack is Excel, SQL, and then some sort of like a BI or visualization tool like Power BI or Tableau. Now, you've mentioned SQL as well for data science. You mentioned Python, right? Maybe instead of Excel. Is there something else, that, like another tool that you think scientists need in their tool belt? Or is it really mostly just SQL and Python?
I would say there's a lot of like side tools. Like, you should understand the command line. You should understand Git. I'd say for the BI tools like Power BI or Tableau, that's optional for data scientists, because there's just a lot of different data science roles. I think all data scientists should be aware of them, but then there are some more data science roles that are more exploratory. And yes, you could specialize in some BI tool that like connects to a database, things like that. But then there are a lot more machine learning heavy data science roles too. And then you won't be using visualization as much, and it's a lot more coding.
Yeah, and I would also, these days, like particularly if you're building and deploying like machine learning algorithms, you probably also want to be pretty comfortable in the cloud and potentially with containerization tools like Docker. But like, I think the overarching kind of narrative of a data science career is that you're always kind of picking up these little edge skills when needed. Tech stacks evolve pretty quickly. And you typically don't need to be a master in these tools like, a computer scientist or software developer would. But you certainly have to be willing to get your hands dirty with something new in order to get a project in. And it can be very fun or very challenging or very frustrating depending on how much time you have to do it and the specific tool at hand. But yeah, you find that you're always kind of picking up like, you might be a very, very proficient in one or two core tools like SQL and Python, but then you have all of these, you're just good enough. You have a couple recipes to get what else you need done. Of course, sometimes people specialize or love the cloud side of things so much that, like, as Alice said, that they like, I really want to become a data engineer or an ML engineer or an analytics engineer because I really love like the building data pipeline aspect of this as opposed to the model training and deployment. And so you kind of get this you're kind of at the center of all sorts of different data roles when you're a data scientist, and you kind of get to choose your own adventure to some extent if you want to, and you start picking up technical skills and want to move in that direction.
Yeah, I see data analysts as more of like the generalist path, and you can, like with your core Excel, maybe some SQL and data viz tool, you can be great at a lot of roles. And then data science is very specialized. It's like you learn these tools and you're good at this job. And like Chris said, it's like then you go to this other job and then it's like a different set of tools. But as long as you know the basics of like machine learning, Python, and SQL, you pick it up on the job. But it gets a lot more specialized.
Okay, I like it. Yeah, and I was just looking at the polls here, and actually, it looks like for the first one we asked, where are you in your data career journey? We have almost 40% of the audience saying learning new skills. Now, I think you both have a unique perspective because the traditional way of learning new skills was school, right? Getting a degree, and you both have specialized degree in analytics, data science. But now you're both online instructors teaching. In your case, Chris, both analytics and data science. Alice, you're one of our machine learning instructors as well. So how do you think for folks that are taking this new, I guess, more modern avenue or approach towards learning, where are the gaps to traditional, academic education, and how can they fill those gaps? And what are some of the advantages of taking these new courses? Alice, I'll hand it over to you first.
Sure. So I'm in kind of a unique situation right now because I create these online classes for Maven Analytics, and I also teach the machine learning graduate at a machine learning graduate program. So it's just interesting because those are two very different paths you can take to get to the same destination. So I would say for the traditional university setting, some of the things that comes with is you get a degree at the end, you have this built-in network, there's this very structured path for you that you have to follow, and you're graded. So it's just like pressure to get those done, and then those projects done, and then you have a lot of practice, and that's all kind of built in. So that's the traditional path. And then on the other hand, you have like the online learning path, which is so much more popular these days. And I think the difference is there is a lot of those things that you get with a degree, you have to figure out on your own. But it's absolutely possible. It's just a little bit more like you have to take a little bit more initiative. So for things like getting a degree, you get certifications. For things like networking, LinkedIn and the Maven community and other communities out there, they're just amazing networking opportunities. In terms of holding yourself to a schedule and getting practice, that's, I think, the key for learning online these days. It's like you take a class, but to really understand it, you really do need to practice projects on your own. And I always say, like, if you just really struggle through like 5 projects on your own, I think you'll understand what it takes to be a data analyst or a data scientist. You just need to go through that entire process of not someone telling you like, hey, this is the question, go from here. Really, you want to just start with your own question, scope out the project, gather the data, and then like go basically the full path like 5 times, and then you'll be able to practice and really become a data analyst or data scientist.
Yeah, I think you hit the nail on the head there. I think the two biggest differences, right, is the credential, right? So a university degree is a very powerful signal that you've completed the requisite requirements to do A or B. The other thing is the network and community, right? So like one of the things that I think I loved most about my university program was the fact that like I have all of these classmates who are studying the same things, learning the same things at the same time. And as I talk to them and bounce ideas off of them, maybe some days I'm asking them questions, maybe some days they're asking me questions. But on both ends of that exchange, I'm learning more and I'm cementing my own knowledge. And so, when you are doing self-study, I think as much as you can, like try to find a buddy or a colleague or somebody on LinkedIn. Hopefully we'll have some additional functionality on our site soon that allows to facilitate this. But basically, like, it's so important to have somebody look at a project of yours and say, hey, like, here are a couple of things that I think, other ideas to explore. Like, even as a practicing data scientist, when I'm working on a project, one of the most important things I can do is sit down with that analyst, my manager, say, hey, here's where I am with this project. Like, I'm really struggling with this, or I don't quite understand why the data looks like this. And reasoning through that is something that is really hard to replicate with pure self-study. And that's especially true, as Alice said, when you start moving into projects that you yourself are creating. So it's one thing to kind of work in a guided project or a project in one of our courses, but when you kind of go out into the wild and there's all this ambiguity about, what is even the right algorithm to solve this problem, or what is the right question to be asking about this data, that's where having somebody with you can be very helpful, or a community around that. And in terms of a credential, like, you don't have a degree when you're studying online, and certificates are good, but a better credential is projects, a project portfolio. Show people that you can do the work that you say you can, because you don't have that degree that, is accredited and hopefully from a reputable institution that already has employed people through this, like a company before. So having a strong project portfolio and a community are like two of the things that I would really suggest for people who are taking online courses, because I think that's the way that you learn better, and that's the way that you signal to employers that you can do the work without a strong credential like a degree. And the other thing I'll say really quick is that I think we're gonna jump into that soon, but yeah.
I mean, I was just going to say, so you kind of already touched on it with the project portfolios and kind of how you can set yourself up for success if you're trying to become employed. So, and I can send this right back to you, Chris. So if someone is trying to land that data scientist role, they've already learned the skills that they needed to learn. They decided that this is a career path for them. So what things should they focus on to improve their chances of success? And is it maybe different from data scientists to data analysts?
Yeah, I mean, I think that like in general, the bar for entry for data science roles is going to be a little bit higher than like an entry level data analyst role. Certainly you need to be very good. Like, you need to do a ton of practice with technical questions related to Python and SQL. That's going to be, so when you apply for a data science role, you'll talk with a recruiter, and then typically the next step for almost any company is a phone technical screen. And they're going to ask you a couple of, usually like they'll start with an easy SQL question, then they go to intermediate, and they'll do the same for Python. And that's just proving whether or not you know the skill well enough. And then you'll go to an on-site interview, and that's where you get to show who you are. That's typically how it goes. So if you aren't proficient enough to make it past those phone screens, you're going to have a really hard time landing a role. But the other thing I would say is, like, if you want to get into data science without a data science degree, it really behooves you to probably have some experience as an analyst. It's going to be very difficult to get into a data science role without any experience working with data. I've seen a lot of people transition from data analyst to data scientist, whether they might have a pretty strong technical background and pick up some data science skills along the way. But it's really hard to just jump into a highly technical role without that and without that degree. But if you are going to try, you need to make sure you have a strong portfolio and really network hard to do that.
Yeah, I would agree with that. I think the portfolio is everything. And I'd say for that portfolio, it's important not to just like do the analysis and be like, I checked all the technical boxes, but be able to explain all the decisions you made along the way. That's something that you talk about in interviews a lot. And I think, like we talked about this earlier, it's like the first level of getting a job is you have to have the technical skills, which is analyst. You need Excel. For maybe SQL, and then for data scientists, it's Python, SQL. And then from there, it's really like, can you answer questions at work in a simple way, right? Like a lot of times I think what happens with people who are just starting out in data and data analysis and data science is they're like, oh, we learn all these cool tricks. We have to apply everything, right? But most of the times that's not the answer. Like most of the time, the simple solution is the best one. And so whenever I'm seeing interviewees and then they're talking about these fancy algorithms or all these technologies they're using, I'm like, was that really necessary? Like, you know what I mean?
Yeah, that's so true. And I think the other, like, and that reminds me, like, yeah, your portfolio is a very good, like, conversation starter and discussion point in interviews. And a lot of times you're very rarely asked about like, you know, the technical details of training your model, but it's more like, why did you choose precision as your metric of interest instead of accuracy, right? And a lot of the times, like discussions about like higher level project design, like how you're thinking about approaching this data and what problems you're trying to solve with data science tools are much more important and indicative if you're going to be successful in a data science role. So the why behind what you're doing versus, you know, like, yeah, I did like a cross validation loop and I tried 1,000 combinations of hyperparameters. Like nobody cares. Like that stuff is like, it's important for you to know, but most people want to know how you think about the problems you're working on. And that, because that's where data scientists really add value compared to one another versus like everyone can kind of, you know, most people have the same relative technical skills in terms of, I'm going to try a couple models. I'm going to get them, you know, I can optimize a training metric and out of sample accuracy or whatever the metric is. But the question is, can you look at a problem and identify what the right solution for this is? And maybe the answer is, I'm not going to use a model at all. We don't need one here. We can use a simple business rule. And that's the kind of thing that people are often looking for in data scientists is like, can you think critically about a problem in order to like deliver the most value based on what the limitations are, who the stakeholders are, et cetera, and being able to think through that and talk about that is a huge skill that, to your point, Alice, like when you're a junior, you're just trying to think about like, here's all the stuff I learned and here's all the stuff that I know, but like that kind of shows that you don't know a lot about what goes on in this role. So thinking about the why is super important, and being able to articulate that is often what really helps separate you from other candidates.
And while you're saying that, it just reminded me of like portfolio projects that really stand out to me, because I think a lot of times with portfolio projects, people will start with the data set and they'll be like, oh, I have this Titanic data set and I'm going to do some analysis on it, right? And you see those projects again and again and again. But the ones that really stand out are the ones that are just asking the why, like you said. Like that's something I always try to do with my personal analysis projects. Like I had a question that was like, how are stand-up comedians different from each other? And that's a very broad question. And then from there, I have to think, okay, which comedian should I look at? Where am I going to get this data? Should I apply an algorithm or should I just do some simple analysis, right? And from there, then like that's really what I'm talking about. Like when you should go from the beginning to the end of a project, like start with that high level question, dive into it, and then like know why you're making these decisions along the way. Why are you using this data set? Why are you using this algorithm or not? And things like that.
I think that's super interesting. Yeah. And I mean, to that point, because Alice, you mentioned, I mean, you wouldn't think that who is the best comedian or the most popular comedian has something that a data science project would entail. But I think it's a great, and we talked about this last week with Chris Dunn, like passion projects are a very, I think, key part of getting the ball rolling in terms of getting a project portfolio. So are there any more, I mean, maybe not suggestions, but things that you could talk, because I know you do these all the time, right? You've done these Taylor Swift analyses, like how can you take something that might sound as serious in data science and apply a very real project to something that is something more that you're passionate about, not necessarily, to your point, the Titanic data set that you see all the time?
I mean, I think you have to go in thinking maybe I might not use data science and be okay with that. Like I'm just practicing my data skills, because I think when people try to force data science into a project, then that's when things go wrong, and it's not that the end result isn't as personable. So I would say you should just go in thinking, okay, I've now learned all these tools and technologies. I have them in my tool belt. Now I'm going to explore some data and let's see where it goes, and be okay with where that lands. And then every single time you're going to learn something new, like guaranteed.
Yeah. And when we were at the boot camp, like when people were working on their capstone projects and asking what they should do, like I would always tell them to do something that they're knowledgeable or passionate about, and ideally both. Right. The other thing we talk about a lot in our courses, right, is the importance of domain knowledge when you're solving really any problem. And so when you're tackling, like, again, people aren't really going to care what your portfolio project is on as long as the work and the reasoning behind it are strong. And so what I find is that when people work on projects they're both passionate and knowledgeable about, they ask better questions, they make better decisions, they dig a little bit deeper, they're a little bit more curious, And all of those things like contribute to and show employers what you'll be at your best on the job, right? When you really like feel like you own this project versus like if I explore like the Titanic data set, like I wasn't there. Like, I mean, first of all, it's like everyone's seen the data set, like there's only a couple hundred rows, right? But like if I were to explore, like I'm not really big on baseball, right? So like if I were to build a baseball, like a model to predict someone's batting average, or I don't even know if that's a good question to ask, right? Like I would do such a worse job than somebody that knows baseball deeply. That like if you put our two projects next to each other, even if we have the same technical skill and the same critical thinking skills, someone who is like understood baseball for a few years and lives and breathes it and is passionate about it is going to bring so many new questions and thoughts about it to that problem that I could. And that's really important when you're trying to showcase how you are going to perform and look on the job.
Yeah, and that reminds me, like one thing I always say about data is when you start a project, you don't want to start with the data because that really limits what you can do with your analysis. Whereas if you don't look at data, you just start by brainstorming, then you think, oh, I can get data from here and here. Like if you're into baseball, then like Enrique, you probably know all the places on the internet where you can get baseball data, and then you'd have to bring them together. And that's going to have you practice your SQL skills, right? And data cleaning skills. And those are things that I think we always say in our courses, like data cleaning takes a long time, but then when you actually experience it, you're gonna go through the struggle and then come out better on the other side.
Yeah, I think that's great. And to your point, it's hard not to start with the data, right? Because it's what you're almost training to do eventually. But I think, and I've been guilty of this as well, but now that you bring up the baseball project, like even some of the projects that I've been most excited about just doing myself, are because I started with some sort of question or objective in mind. And that's what kind of drives you to perform the analysis. And it's funny because now that the baseball playoffs are starting, I did this, I have this fantasy baseball league with my friends, and I wanted to try to see if I could just use data analysis to like pick my team and make all the moves and see if I came out on top. I ended up losing in the playoffs. Technically a tie, lost at the end, but I've learned from it and I'll make some improvements for next year and I'll share that with you guys. But yeah, and it all started with, how can I be as good as I possibly can in fantasy baseball while making it like paying it the least attention to it and just trusting the data. So it's a good point. And I think it's a perfect segue into our Q&A session because we've got a lot of projects about questions about portfolios here and, finding data sets and how to get started. So I'll segue into that. We've got Philippe here saying, yes, portfolios are great, but when 95% of your work is under lock and key, maybe it's confidential, you're doing projects as part of your company, how do you showcase your skills then?
Yeah, that's a great question. I mean, obviously, like you can talk about your project work in interviews, but you can't, download your company data and put it on a website, right? That would probably be a no-no, and probably also make employers be like, this guy, I can't trust them. So yeah, unfortunately, that's going to require you like crafting your own data set. Obviously, some places you can get data sets like from our data playground or from, places like Kaggle, but the other, a good flex of your skills as well is to like scrape data or collect data via an API. And again, that's where I suggest leading into something you're passionate about. So like when you're working on a project, you're like, oh, I actually wanted to learn about this versus like, this just feels like homework. But in other cases, companies will actually give you take home projects as part of interviews. But like, I would just suggest like, as a matter of course, like working on at least one project, particularly if you already have experience in this field, you might not need as much of a portfolio as somebody who's trying to break in. But crafting your own data set via web scraping and finding some interesting sources that something that you're interested about hopefully lightens the burden there. But unfortunately, yeah, like it's going to be really hard to showcase your skills without putting something out there. And yeah, you can't use your personal data or your company's data. I mean,
Yeah, I'd agree with that. It's a lot of like a side project. And for that side project, there are different ways to gather data. So that's good experience. And then like maybe if you're talking about that, then you can reference something you're doing at work, but yeah, not explicitly.
As an example, like one of the coolest side projects I've heard about is like one of my colleagues was looking to buy a used car. And so they scraped Craigslist for all the cars, for like all the trucks. He was looking for a truck specifically. So they scraped all the trucks that were on sale within think like 300 miles. That's 500 kilometers for people who are not from America, right? And he built a linear regression model and then predicted the value of the car based off of things like how many miles were driven, how old it was, the trim, et cetera. And then he identified cars that seemed to be very underpriced and ended up saving like $2,000 on a car because he scraped data and built a regression model and then purchased the car that had like the biggest negative residual, indicating it was undervalued on the market. And so there are things you can do like that, right? That like, yes, you paid for your own time by doing that. That might kind of accomplish two goals. You learn about something and you get a project there.
I love it. That's actually really fascinating. Mark that done. And this is a very similar one. So what makes a great product portfolio? Where do we pick data sets from, and any other advice? I know, Alice, you've already talked about maybe not even starting with the data, right? And like think about a question and then see where you can find it. I know we've talked about scraping, but are there any other sources that you'd recommend that you've maybe used in the past? I know we've got some internally at Maven as well, but I don't know if you have any other suggestions, or maybe just the scraping piece that you've already said.
Yeah, I would say there's I feel like there's a lot of unique data sets out there. And often if you just Google like something like clustering project data set, like those are going to be just your canned data sets that often they'll come with a prompt already. And then as people who interviewees, like we see those come through all the time. But then the ones that really stick out are the ones that find more niche data sets. And sometimes you don't have to scrape them or use an API to get them if you don't have those skill sets yet. So, but if you start with a question, like I remember when I first started doing analysis projects on my own, I was looking at pop artists and how they were performing and how they all compare to one another. And so I just started looking for pop star data. And then I came to a Wikipedia site. And then I didn't know how to scrape at that point yet. This was 10 years ago. So I just copied that Wikipedia data set. And then I found another data set from like Billboard. And I just did some copy pasting because I didn't know how to scrape yet. But then just with all that, I created this custom data set. And that now is like what I look for from people. It's like that stands out because you've joined a few different data sets and it's not just like a canned response. It's you've put thought into it and you've scoped it out.
Yeah. And I will say like, it's not necessarily bad to have one or two kind of like fairly basic or paint by numbers product. Like sometimes we do start with the data, particularly when we don't like in a business, you should not be starting with the data. Like you should be thinking about what your business's challenges are. But like practically speaking, and when we don't have data generated that we can just jump into, right? Like it's okay to like have a project that a couple, other people have done on your portfolio. But I think the key is like not having only those very classic projects that everybody has done. Try to have at least something in your portfolio that's unique. But you don't necessarily need to make sure every project is unique, but certainly you want to make sure that like you're avoiding the beaten path and it's not just Titanic, Iris, like all those other famous data sets and that's it. Like you want to, and to your point, Alice, sometimes if you just go like on Kaggle and you like search for something and you go to like page 10, you'll find a data set that is pretty good and only like 2 or 3 other people have worked with. And that can be enough to differentiate you versus just going to those top, very famous data sets that everybody has taken a crack at.
Yeah, and I will just shameless plug here for the data challenges at Maven. I think those are a great way of like starting with the question because they're based around something that you're trying to solve or a question that you're trying to answer, and they provide the data set for them. The last one that we just had, we had people build clustering models for, right? So those are great ways to showcase your skills. Those were in a business setting. We actually have one now. We have this Halloween candy challenge that I know for a fact, Alice, you've done a project on as well, right?
Yeah, I'm looking forward to going through my walkthrough this week.
All right. Done answering that. Let's see. Have you guys found any questions that maybe you'd like to answer, or want me to throw another one up there? Let's see. Like this one. What is the key skill, the most important that a data analyst should have or develop? So what should, and that you can kind of take as a first step to developing a career?
Ooh, to narrow it down, I'm thinking like from a technical perspective, I feel like Excel, but then from a non-technical perspective, it's really critical thinking, like being able to, yeah, like really dig into a problem and not see it just at surface level.
Yeah, I think like it's like developing this like curious instinct about like, yeah, like what this data represents, what does it mean, how could it potentially be misleading me, and how can I use this to, answer like or further some goal of my business or organization, right? Like it's a mindset that takes some time to cultivate, but ultimately like, the difference between someone who's technically good but not an analyst is like you just move data around and you can do anything you want with SQL, but like if you can't think about what that data means and what it represents in terms of what your business is doing or what it needs to do or how improving that data can drive your business forward, right? Then like you're not really analyzing the data, and like ultimately like even somebody without technical skills that can look at a spreadsheet and ask those questions might have more of a potential as an analyst than someone who is like the best coder ever. And sometimes when I work with my engineers, I'm actually like surprised about how they think about data versus how we do. And that's certainly like, I think the most important thing is cultivating the analytical mindset. So thinking like an analyst, folks, is a great way to kind of learn how to do that there.
Love it. There's an interesting one here as well. So the part that gets me annoyed about data science, and the reason that I'm a little bit more inclined towards data engineering, is that the algorithms are more like a black box in data science, and it's hard to explain how we're reaching those results. Now, Alice, you've talked about how some of the best solutions are simple solutions, but how do you transmit that as a data scientist when really the models that you're using can be a little bit hard to grasp, from maybe someone from another perspective, like a data analyst? Like, how do you communicate those to your stakeholders if you're using maybe black box models, which maybe that should never be the case?
Yeah, I mean, I guess there's different situations. Like some that you do have those more simple models, like your linear regression or your clustering that has more simple explanations, and then there's those black box models. I would say if you're doing like some pretty intense predictions, then maybe you are doing those black box models. But then for the most part, if you are working in this business setting where you are doing data analysis for insights, then you're using these simpler models that you can better explain. And there's just different data science. Like I think if you focus on explaining them, you can explain them to some extent. Like there's pieces that you can't explain.
Yeah, and there's like tools that help interpret more black box models. But like in my course, I talk about how there's two primary goals of modeling. One is interpretation, so you're trying to learn more about what factors influence what you're trying to predict. And then there's predictive accuracy. And often those two goals are competing, right? So I think this question really gets at the heart of that, which is like the most accurate models also tend to be the most complex, right? They can determine more complex decision boundaries. They can handle more features, more interactions. But in my professional experience, what I found that I really enjoy doing, and I make it a practice, is I always start with a linear interpretable model when I'm tackling a data science project. In some cases, I've been asked to, because before I can sell that like I'm going to build a predictive model that's going to change this process, I first need to get people comfortable with it. And in order to do that, I need to show them a model that like what is being predicted and what factors influence this. And when they understand that, like I kind of talked about this earlier, but like, 8 of those factors are some things that I know for sure we've seen through our domain knowledge are very important. 8 of these variables influence this target variable, this thing I'm trying to predict. Before I can just go to this black box model. But then from there, it's like once I sell that, then I get to focus more on getting the most accurate model possible, which is when I'll turn to more tree-based models, ensemble methods, et cetera. But I think for me, just approaching a problem like a linear regression or a logistic regression is a very powerful exploratory analysis tool that just helps me understand in a very concrete fashion the relationship between my variables and my target before I really start going hardcore with more advanced machine learning methods. So I think and to your point, like it is a little bit less satisfying to just throw like a very complex algorithm at a problem, knowing that it's going to be more accurate than, very well crafted and well thought through linear model. So yeah, it can feel a little bit like, of a bummer, but ultimately you can still get a lot of those insights if you take the step to build something interpretable that's also fairly accurate before going nuts with the black box model.
And that simple model will usually get you like 60 to 80% of the way there. And then it's just,
Amazing. Well, I think we're almost at time. So before people start dropping off, I think we can end our QA there. Chris, Alice, this was amazing. Thank you for your time. For anyone that wants to continue to hear Chris and Alice, we've got a full data analysis in Python stack by Chris Bruehl, where you'll get to hear his voice. And we've got both of them as our data science instructors in our whole data science path. We've got guided projects that you can complete as part of your portfolio. And in general, they're just amazing courses that I had, honestly, the privilege of working on. And I learned a lot just by doing their slides. So I can't even imagine how much you can learn if you're interested in data science by actually taking the full courses and following along with other projects. So yeah, thanks for hopping on, guys.
Yep, our pleasure.
All right. Thanks, everyone.
See you, everyone.